Extended display identification data is a data structure provided by a digital display to describe its capabilities to a video source. It is what enables a modern personal computer to know what kinds of monitors are connected to it. EDID is defined by a standard published by the Video Electronics Standards Association. The EDID includes manufacturer name and serial number, product type, phosphor or filter type, timing supported by the display, display size, luminance data and pixel mapping data. EDID structure versions range from v1.0 to v1.4. All these define upwards compatible 128-byte structures. EDID structure v2.0 defined a new 256-byte structure, but subsequently has been deprecated and replaced by v1.3. HDMI 1.0 Euro 1.3c uses EDID structure v1.3. DisplayED is a standard targeted to replace EDID and EDID extensions with a uniform format suited for both PC monitor and consumer electronics devices. Background: the channel for transmitting the EDID from the display to the graphics card is usually the ES2C bus, defined in DDC2B. Before DDC and EDID were defined, there was no standard way for a graphics card to know what kind of display device it was connected to. Some VGA connectors in personal computers provided a basic form of identification by connecting 1, 2 or 3 pins to ground, but this coding was not standardized. The EDID is often stored in the monitor in a memory device called a serial PROM or EEPROM and is accessible via the ES2C bus at address 0x50. The EDID PROM can often be read by the host PC even if the display itself is turned off. Many software packages can read and display the EDID information, such as EDID for Linux and DOS, PowerStrip for Microsoft Windows and XFRE86 for Linux and BSD Unix. Mac OS X natively reads EDID information and programs such as SwitchResX or DisplayConfig-X can display the information as well as use it to define custom resolutions. Enhanced EDID was introduced at the same time as EDDC. It introduced EDID structure version 1.3 which supports multiple extensions blocks and deprecated EDID version 2.0 structure. Data fields for preferred timing, range limits, monitor name are required in EDID. EDID also supports dual GTF timings and aspect ratio change. With the use of extensions, EDID string can be lengthened up to 32 kbytes. EDID extensions assigned by VESA, timing extension, additional timing data block, video timing block extension, EDID 2.0 extension, display information extension, localized string extension, microdisplay interface extension, display transfer characteristics data block, block map, display device data block, extension defined by monitor manufacturer. According to LSEXT, actual contents varies from manufacturer. However, the value is later used by DDDB. Revision history: August 1994, DDC Standard Version 1 a Euro EDID v1.0 structure. April 1996, EDID Standard Version 2 a Euro EDID v1.1 structure. 1997, EDID Standard Version 3 a Euro EDID structures v1.2 and v2.0, February 2000, EEDID Standard Release v1.0 a Euro EDID structure v1.3, EDID structure v2.0 deprecated, September 2006 a Euro EDID Standard Release v2.0 a Euro EDID structure v1.4, limitations. Some graphics card drivers have historically coped poorly with the EDID, using only its standard timing descriptors rather than its detailed timing descriptors. Even in cases where the DTDs were read, the drivers were still often limited by the standard timing descriptor limitation that the horizontal-vertical resolutions must be evenly divisible by 8. This means that many graphics cards cannot express the native resolutions of the most common widescreen flat panel displays and liquid crystal display televisions. The number of vertical pixels is calculated from the horizontal resolution and the selected aspect ratio. To be fully expressible, the size of widescreen display must thus be a multiple of 16A, 9 pixels. For 1366A, 768-pixel wide XGA panels, the nearest resolution expressible in the EDID standard timing descriptor syntax is 1360A, 765 pixels, typically leading to 3-pixel thin black bars. Specifying 1368 pixels as the screen width would yield an unnatural screen height of 769.5 pixels. Many wide XGA panels do not advertise their native resolution in the standard timing descriptors, instead offering only a resolution of 1280A, 768. Some panels advertise a resolution only slightly smaller than the native, such as 1360A, 765. For these panels to be able to show a pixel-perfect image, the EDID data must be ignored by the display driver, or the driver must correctly interpret the DTD and be able to resolve resolutions whose size is not divisible by 8. Special programs are available to override the standard timing descriptors from EDID data. Even this is not always possible, however, as some vendors' graphics drivers require specific registry hacks to implement custom resolutions, which can make it very difficult to use the screen's native resolution. EDID 1.3 data format: when used for another descriptor, the pixel clock and some other bytes are set to 0. Currently defined descriptor types are 0xFF, monitor serial number, 0xFA, unspecified text, 0xFD, monitor range limits. 6 or 13-byte binary descriptor. 0xFC, monitor name, padded with OA 2020. 0xFB, additional white point data. 2 5-byte descriptors, padded with OA 2020. 0xFA, additional standard timing identifiers. 6 2-byte descriptors, padded with OA. EIA-CEA 861 extension block. The CEA EDID timing extension was first introduced in EIA-CEA 861, and has since been updated several times, most notably with the A861B revision, A861D, A861E, and A861F, which was published on June 4, 2013. According to Brian Mark Walter, Senior Vice President, Research and Standards, CEA, A864F includes a number of noteworthy enhancements, including support for several new Ultra HD and widescreen video formats and additional colorimetry schemes. Version 1 allowed the specification of video timings only through the use of 18-byte detailed timing descriptors. In all cases, the preferred timing should be the first DTD listed in a CEA EDID timing extension. Version 2 added the capability to designate a number of DTDs as native, and also included some basic discovery functionality for whether the display device contains support for basic audio, YCBCR pixel formats, and underscan. Per version 3, there are 2 different ways to specify the timings of available DTV formats, via the use of 18-byte detailed timing descriptors as in version 1 and 2, and via the use of the short video descriptor. HDMI 1.0-1.3c uses this version. Included in version 3 are 4 new optional types of data blocks: video data blocks, audio data blocks, speaker allocation data blocks, and vendor-specific data blocks. CEA EDID timing extension version 3 data format. Byte sequence, 00, extension tag. 2 hours for CEA EDID, 01, revision number. 3 hours for version 3, 02, byte number D within this block where the 18-byte DTDs begin. If no non-DTD data is present, in this extension block, the value should be set to 4 hours. If set to 0 hour, there are no DTDs present in this block and no non-DTD data. 03, number of DTDs present, other version 2 plus information, bit 7, 1 if display supports underscan, 0 if not, bit 6, 1 if display supports basic audio, 0 if not, bit 5, 1 if display supports YCBCR 444, 0 if not, bit 4, 1 if display supports YCBCR 422, 0 if not, bit 30, Total number of native formats in the DTDs included in this block, 04. Start of data block collection. If byte 02 is set to 4 hours, this is where the DTD collection begins. If byte 02 is set to another value, byte 04 is where the data block collection begins, and the DTD collection follows immediately thereafter. The data block collection contains one or more data blocks detailing video, audio, and speaker placement information about the display. The blocks can be placed in any order, and the initial byte of each block defines both its type and its length. Bit 75, block type tag, 1 is audio, 2 is video, 3 is vendor specific, 4 is speaker, allocation, all other values reserved. Bit 40, total number of bytes in this block following this byte. Once one data block has ended, the next byte is assumed to be the beginning of the next data block. This is the case until the byte where the DTDs are known to begin. Any audio data block contains one or more 3-byte short audio descriptors. Each SAD details audio format, channel number, and bit rate resolution capabilities of the display as follows: SAD byte 1, bit 7, reserved, bit 63, audio format code, 1 equals linear pulse code modulation, 2 equals AC3, 3 equals MPEG1, 4 equals MP3, 5 equals MPEG2, 6 equals AAC, 7 equals DTS, 8 equals ATRAC, 0, 15, reserved, 9 equals 1-bit audio also known as SACD, 10 equals DD+, 11 equals DTS HD, 12 equals MLP Dolby True HD, 13 equals DST audio, 14 equals Microsoft WMA Pro, bit 20, number of channels minus 1, that is 000 equals 1 channel. 001 equals 2 channels. 111 equals 8 channels. SAD byte 2, bit 7, reserved, bit 6, 192 kHz, bit 5, 176 kHz, bit 4, 96 kHz, bit 3, 88 kHz, bit 2, 48 kHz, bit 1, 44 kHz, bit 0, 32 kHz. SAD byte 3, for LPCM, bit 7-3 are reserved and the remaining bits define bit depth, bit 2, 24-bit, bit 1, 20-bit, bit 0, 16-bit. For all other sound formats, bit 70 designate the maximum supported bit rate divided by 8 kbits. Any video data block will contain one or more 1-byte short video descriptors. They are decoded as follows: bit 7, 1 to designate that this should be considered a native resolution, 0 for non-native, bit 60, index value to a table of standard resolutions timings from CEIA 861F. Code picture pixel, short aspect name ratio HXV@F. 1 DMTO 659 43640x 480p at 59.94/60 Hz, 2 480p 43897 720x 480p at 59.94/60 Hz, 3 480p H6932 37 720x 480p at 59.94/60 Hz, 4 720p 6911 1280x 720p at 59.94/60 Hz. 5 1080i 16911 1920x 1080i at 59.94/60 Hz, 6 480i 4389 720, 1440, x 480i at 59.94/60 Hz, 7 480i H6932 37 720, 1440, x 480i at 59.94/60 Hz, 8 240p 4389 720, 1440, x 240p at 59.94/60 Hz, 9 240p H6932 37 720, 1440, x 240p at 59.94/60 Hz, 10 480i 4x 4389 x 480i at 59.94/60 Hz, 11480 I4XH693237X480i at 59.94/60 Hz, 12240p 4X4389. X240p at 59.94/60 Hz, 13240p 4XH693237X240p at 59.94/60 Hz, 14480p 2X4389 1440x480p at 59.94/60 Hz, 15480p 2XH693237 1440x480p at 59.94/60 Hz, 161080p 1691. 11920x 1080p at 59.94/60 Hz, 17576p 431615 720x 576p at 50 Hz, 18576p H16964 45 720x 576p at 50 Hz, 19720p 5016 1280x 720p at 50 Hz, 201080i 2516 1920x 1080i at 50 Hz, 21. 576i 431615 720, 1440, x 576i at 50 Hz, 22 576i H16964 45 720, 1440, x 576i at 50 Hz, 23 288p 431615 720, 1440, x 288p at 50 Hz, 24 288p H16964 45 720, 1440, x 288p at 50 Hz, 25. 576i 4x 431615 x 576i at 50 Hz, 26 576i 4x H16964 45 x 576i at 50 Hz, 27 288p 4x 431615 x 288p at 50 Hz, 28 288p 4x H16964 45 x 288p at 50 Hz, 29 576p 2x 431615. 1440 x 576p at 50 Hz, 3576p 2x H16964 45 1440 x 576p at 50 Hz, 31 1080p 5016 911 1920 x 1080p at 50 Hz, 32 1080p 2416 911 1920 x 1080p at 23.98/24 Hz, 33 1080p 2516 911 1920 x 1080p at 25 Hz, 34 1080p 3016 911 1920 x 1080p at 29.97/30 Hz, 35 480p 4x 4389 x 480p at 59.94/60 Hz, 36 480p 4x H169 3237 x 480p at 59.94/60 Hz, 37 576p 4x 431615 x 576p at 50 Hz, 38 576p 4x H16964 45 x 576p at 50 Hz, 39 1080i 2516 911 1920 x 1080i at 50 Hz, 40 1080i 5016 911 1920 x 1080i at 100 Hz, 41 720p 116 911 1280 x 720p at 100 Hz, 42 576p 104 720 x 576p at 100 Hz, 43 576p 100 H169 3237 720 x 576p at 100 Hz, 44 576 I 54 316 15 720, 1440, x 576 I at 100 Hz, 45 576 I 50 H16 964 45 720, 1440, x 576 I at 100 Hz, 46 1080. I 60 16 911 1920 x 1080 I at 119.88/120 Hz, 47 720p 120 16 911 1280 x 720p at 119.88/120 Hz, 48 480p 119 43 16 15 720 x 480p at 119.88/120 Hz, 49 480p 119 h 16 964 45. 720 x 480p at 119.88/120 Hz, 5480 f 59 4389 720, 1440, x 480R at 119.88/120 Hz, 51 480 f 59 h 16 932 37 720, 1440, x 480R at 119.88/120 Hz, 52 576p 204 3 16 15. 720 x 576p at 200 Hz, 53 576p 200 h 16 964 45 720 x 576p at 200 Hz, 54 576 104 3 16 15 720, 1440, x 576i at 200 Hz, 55 576 100 h 16 964 45 720, 1440, x 576i at 200 Hz, 56. 480p 239 4389 720 x 480p at 239.76/240 Hz, 57 480p 239 h 16 932 37 720 x 480p at 239.76/240 Hz, 58 480 119 4389 720, 1440, x 480R at 239.76/240 Hz, 59 480 119 h 16 932 37 720, 1440, x 480R at 239.76/240 Hz, 6720p 24 16 911 1280 x 720p at 23.98/24 Hz, 61 720p 25 16 911 1280 x 720p at 25 Hz, 62 720p 30 16 91. 1280 x 720p at 29.97/30 Hz, 63 1080p 120 16 911 1920 x 1080p at 119.88/120 Hz, 64 1080p 116 911 1920 x 1080p at 100 Hz, 65 720p 24 64 27 43 1280 x 720p at 23.98/24 Hz, 66. 720p 25 64 27 43 1280 x 720p at 25 Hz, 67 720p 30 64 27 43 1280 x 720p at 29.97/30 Hz, 68 720p 50 64 27 43 1280 x 720p at 50 Hz, 69 720p 64 27 43 1280 x 720p at 59.94/60 Hz, 70. 720p 164 27 43 1280 x 720p at 100 Hz, 71 720p 120 64 27 43 1280 x 720p at 119.88/120 Hz, 72 1080p 24 64 27 43 1920 x 1080p at 23.98/24 Hz, 73 1080p 25 64 27 43 1920 x 1080p at 25 Hz, 74 1080p 30 64 27 43 1920 x 1080p at 29.97/30 Hz, 75 1080p 50 64 27 43 1920 x 1080p at 50 Hz, 76 1080p 64 27 43 1920 x 1080p at 59.94/60 Hz, 77 1080p 164 27 43 1920 x 1080 p at 100 Hz, 78 1080p 120 64 27 43 1920 x 1080p at 119.88/120 Hz, 79 720p 24 64 27 64 63 1680 x 720p at 23.98/24 Hz, 8720p 25 64 27 64 63 1680 x 720p at 25 Hz, 81 720p 30 64 27 64 63 1680 x 720p at 29.97/30 Hz, 82 720p 50 64 27 64 63 1680 x 720p at 50 Hz, 83 720p 64 27 64 63 1680 x 720p at 59.94/60 Hz, 84 720p 164 27 64 63 1680 x 720p at 100 Hz, 85 720p 120 64 27 64 63 1680 x 720p at 119.88/120 Hz, 86 1080p 24 64 27 1125 60 x 1080p at 23.98/24 Hz, 87 1080p 25 64 27 1125 60 x 1080p at 25 Hz, 88 1080p 30 64 27 1125 60 x 1080p at 29.97/30 Hz, 89 1080p 50 64 27 1125 60 x 1080p at 50 Hz, 90 1080p 64 27 1125 60 x 1080p at 59.94/60 Hz, 91 1080p 164 27 1125 60 x 1080p at 100 Hz, 92 1080p 120 64 27 1125 60 x 1080p at 119.88/120 Hz, 93 2160p 24 69 1138 40 x 2160p at 23.98/24 Hz, 94 2160p 25 69 1138 40 x 2160p at 25 Hz, 95 2160p 30 69 1138 40 x 2160p at 29.97/30 Hz, 96 2160p 50 69 1138 40 x 2160p at 50 Hz, 97 2160p 69 1138 40 x 2160p at 59.94/60 Hz, 98 2160p 24 256 135 1140 96 x 2160p at 23.98/24 Hz, 99 2160 p 25 256 135 1140 96 x 2160p at 25 Hz, 12160p 3256 135 1140 96 x 2160p at 29.97/30 Hz, 101 2160p 5256 135 1140 96 x 2160p at 50 Hz, 102 2160p 256 135 1140 96 x 2160p at 59.94/60 Hz, 103 2160p 24 64 27 43 38 40 x 2160p at 23.98/24 Hz, 104 2160p 25 64 27 43 38 40 x 2160p at 25 Hz, 105 2160p 30 64 27 43 38 40 x 2160p at 29.97/30 Hz, 106 2160p 50 64 27 43 38 40 x 2160p at 50 Hz, 107 2160p 64 27 43 38 40 x 2160p at 59.94/60 Hz. 0. 108 to 127 reserved. Short video descriptors 20 and 39 are both 1920x1080i at 5069 but differ in the amount of vertical, total lines which are 1125 and 1250, respectively. Notes, parentheses indicate instances where pixels are repeated to meet the minimum speed requirements of the interface. For example, in the 720x240p case, the pixels on each line are double-clocked. In the X480i case, the number of pixels on each line, and thus, the number of times that they are repeated, is variable, and is sent to the DTV monitor by the source device. Increased active expressions include a A2 ZAU and a A4 ZAU indicate 2 and 4 times the reference resolution, respectively. The CAA standard included only numbers 1 to 7 and numbers 17 to 22 above, but not as short video descriptors which were introduced in CAIA 861B, and are considered primary video format timings. The CAIA 861B standard included the first 34 short video descriptors above. The CAIA 861D standard included the first 59 short video descriptors above. The CAIA 861E standard included the first 64 short video descriptors above. HDMI 1.0 to HDMI 1.2 uses the CAIA 861B video standard. HDMI 1.3 to HDMI 1.3c uses the CAIA 861D video standard. HDMI 1.4 uses the CAIA 861E video standard. HDMI 2.0 uses the CAIA 861F standard. A vendor-specific data block contains as its first 3 bytes the vendor's IEEE 24-bit registration number, LSB first. For HDMI, it is always 00-OC03 for HDMI licensing, LLC. It is followed by a 2-byte source physical address, LSB first. The source physical address provides the CEC physical address for upstream CEC devices. The remainder of the vendor-specific data block is the data payload, which can be anything the vendor considers worthy of inclusion in this EDID extension block. HDMI 1.3 specifies some requirements for the data payload. See that spec for detailed info on these bytes. VSD byte 1 to 3 IEEE registration identifier, VSD byte 4 to 5 components of source physical address, VSD byte 6, bit 7, supports AI, bit 6, DC 48-bit, bit 5, DC 36-bit, bit 4, DC 30-bit, bit 3, DCY 444, bit 2, reserved, bit 1, reserved, bit 0, DVI dual, VSD byte 7 if non-zero, VSD byte 8, bit 7, latency fields, bit 6, latency fields, set if interlaced latency fields are present. If set, 4 latency fields will be present, 0 if bit 7 is 0, bit 5-0, reserved, VSD byte 9 video latency, VSD byte 10 audio latency, VSD byte 11 interlaced video latency, VSD byte 12 interlaced audio latency. Additional bytes may be present, but the HDMI spec says they shall be 0. If a speaker allocation data block is present, it will consist of 3 bytes. The second and third are reserved, but the first contains information about which speakers are present in the display device. Bit 7, reserved, bit 6, rear left center/rear right center present for 1, absent for 0, bit 5, front left center/front right center present for 1, absent for 0, bit 4, rear center present for 1, absent for 0, bit 3, rear left/rear right present for 1, absent for 0, bit 2, front center present for 1, absent for 0, bit 1, LFE present for 1, absent for 0, bit 0, front left/front right present for 1, absent for 0. Note that for speakers with right and left polarity, it is assumed that both left and right are present. D-byte where DTDs begin. 18-byte DTD strings continue for an unspecified length until 0000 is the first bytes of a prospective DTD. At this point, The DTDs are known to be complete, and the start address of the 0000 can be considered to be 20, see below, 20-126, post-DTD padding. Should be populated with 0 hour, 127, checksum. This byte must be programmed such that the sum of all 128 bytes equals 0 hour. References: HDMI specification v1.3, DDCCI specifications, EDID software for Linux and DOS, Power Strip for Windows, Switch Res X for Mac OS X shows EDID and customizes display timings, Display Config X for Mac OS X customizes display timings, Brzezinski. Custom resolutions on Intel graphics. Retrieved November 4, 2009 ABCDEVESA Enhanced EDID Standard, Video Electronics Standards Association, February 9, 2000, PA 32, retrieved 2011-11-19 http www.sa.org Standard Listing CEA 861 EASPX, http www.scrapmonster.com C publishes new high-speed SA 861 FDTV interface standard 9294, external links, ederdreader.com a Euro web-based EDID parser.